Hey guys, welcome to the PsyOptions Integration Workshop. I just want to give a quick intro. I'm Tommy, one of the core contributors to PsyOptions, and I have Stockmark with me, who runs the PsyOptions Twitter, makes the best memes, and does all our marketing and relations. For those who don't know, I'm going to give a quick intro of what PsyOptions is. We won the Solana Serum Hackathon, the first Solana season hackathon, back in February or March. And what we set out to build is a peer-to-peer, fully decentralized, trustless options protocol. The genesis behind this was we wanted to automate a options trading strategy in traditional finance called some brokerages. They denied us access. And coming off of the first Solana hackathon back in November, it was a no-brainer to kind of build this next. We launched on mainnet August 22nd. We have a few strikes. Let me see if I can share my screen. We talk through all this. Make sure it's up. Sweet. So we have a few strikes listed. We haven't really exposed too many at this point. Right now, we're just doing a test with a single expiration of September 24th. We have ETH and BTC markets with just 3 strikes on each. And we see some decent volume. What we're really focused on right now is improving capital efficiencies and also reducing the cost of sunken Solana for rent on these accounts. So what happens is, creating one of these strikes, we have to create a PsyOptions option market. We have to create a Serum market. I'll go more into those structures a little bit when we go a little bit deeper into the integration. And we have to, supply the rent for those accounts. And right now, with current Serum state, we have no actual closable markets. So it's a lot of Solana to spin up a single strike. And that's kind of what's holding us back at the moment from just creating all of these ephemeral markets to give a lot of strikes. So liquidity actually isn't the issue at the moment. It's really just some efficiencies and some of the architectures of the programs that PsyOptions integrates with. And so the architecture here is, we have on the user interface that you see, we have the PsyOptions program and the Serum program running on chain. And those two, the UI kind of bridges the gap between those two. And the PsyOptions options program is really the settlement options primitive, foundation for these options, where you can mint an option, you can create a new market, you can exercise them, you can close existing options positions. And all these options are represented as SPL tokens. And that makes it very plug and play into the DeFi system. So that's where it makes no assumptions of how things are traded. We have a Serum market that we create for each of these option markets. And that's what the UI actually pipes into. So you can see these order books live on mainnet. And that's just the actual Serum order books that these option SPLs are trading. So they could trade on an AMM. You could take this option and give it to an investor in escrow. There's a lot you can do with it. But we'll go more into that in a little bit. So we're sponsoring the Ignition Hackathon. So we have a $30,000 prize for people composing on top of PsyOptions. So what we built is this very flexible primitive that can be extended into many different applications. I'll actually cover a list of those that we kind of threw together, we've been thinking about, but don't have the resources at the moment to build ourselves. And maybe that will give people some inspiration into what they want to see. And then I'll also go into a live coding example for these for actually using the PsyOptions primitive, and we'll build an instruction into a brokerage protocol that sits on top of PsyOptions and maybe lets you manage your positions. The PsyOptions primitive doesn't handle like auto exercising or anything like that, so we have to build a protocol on top of it to actually handle that. And then we'll just take questions once we get through all of that. And Stockmark, interrupt me if any good questions come up. So feel free to ping questions in the chat while we're going through this. Happy to stop at any point in time to answer any questions you might have. But the goal here is to really show you a little bit more about PsyOptions, go into the architecture a little bit, and I'll probably cover some a decent bit of like Anchor and using cross-program invocations inside Anchor. So we'll jump right into the we'll go with the ideas for the hackathon first, so they're kind of fresh in your head, and then we'll jump into the actual architecture of PsyOptions, how some of these ideas could work, and then the actual brokerage like instruction that we're gonna write. So at the protocol, there's a lot of there's a lot of projects. Some are user interface related, where like the protocol can already handle these use cases. Some are more protocols or programs built on top of the actual PsyOptions American V1 primitive. And so the first one we have a whole Twitter thread. We can link this and some resources later. But we have a whole Twitter thread about us sponsoring the hackathon and just giving a list of ideas that might be helpful for people to brainstorm on. And the first one is a strategy vault. We see this in, we can take this from like Ribbon Finance on the Ethereum blockchain, where they have some basic strategies that they have a vault delegate that actually handles executing those strategies. They'll select a strategy, and then it's pretty passive for the user to get involved. And these are just running some taker strategies for like selling covered calls or selling secured puts. And a lot of yield is generated by options and these strategies, but options can be very complex for people. So having vaults and strategies that are abstracted away from the base layer and primitive makes it a lot more accessible for people. So like where we see here, all the PsyOptions protocol makes no assumption of pricing. So this can be pretty intimidating for people who have no idea or are new to options trading. So the vaults will really make things a lot easier for passive users just looking to generate yield. The American V1 is also physically settled. So, and it works with any SPL representation. So even though they're like an NFT is also just some metadata wrapped around the SPL specification, NFTs can actually plug and play into PsyOptions American V1. So you could write, someone could, if there's a market for this is still like a subject to be researched, you could actually have someone write a secured put where they lock up some USDC or maybe some other asset. If, Star Atlas is trading their options or their stuff for Atlas at this point, now that they've launched a token, it could be any representation, but basically you lock in some SOL or USDC as a quote in a put contract. And that's basically locking in a floor for an NFT. So then that maker who is providing that put as insurance could then sell it to someone, put it in an escrow account, and sell it to someone. So if you're holding a degen ape and you want to lock in some floor, you could find some insurance provider that could actually integrate just use PsyOptions to write a put for your ape and actually lock in some floor. So we see escrow contracts already in the ecosystem. We have the American V1 and PsyOptions that's physically settled. So the actual programs are already there. This is just more of like a user interface that needs to be built to bridge those gaps and make it actually more usable for users. Also, Mango is good friends of ours, winning the hackathon alongside us back in the day. It's definitely really helpful to have spot trading and options trading in the same interface. So a very simple integration for Mango or PsyOptions would be putting the UIs putting the user interfaces into each other's like domain or UI under some tab or something like that. So that way people can can see all of these options or spot at once and manage it all from one user interface. Another thing, so the primitive is 100% collateralized. So to improve capital efficiency, we need to build some sort of margining system that works. And I'll go more into the 2-token system in a bit, but the point here is we have these writer tokens that denote you actually wrote the contract, denotes that you are short the option. And you can value those tokens. And if you built a borrow lending protocol that was flexible enough to take all these writer tokens, you can actually lock in, people could take the writer tokens, lock them in as collateral, and then get some sort of LTV back. and you kind of create this margining system that is built on top of PsyOptions. It's a little bit more complex, or a little bit easier said than done. We've done some research on the architecture of how this might work, but we have yet to actually have the resources to implement it ourselves. So if there's anyone who's like really curious and are building borrow lending protocols and want to jump on this, definitely reach out to us. Should probably specify that. If you guys want to reach out to us, ping us on Twitter, ping us on Discord, Telegram. We actually have an ignition chat in the Discord for everyone to collaborate, ask questions. So we're always here to provide resources and help. As I've mentioned multiple times, like we don't have the resources to build all of this ourselves, but we can definitely do a lot of advising and helping others who are interested in building on top. I mean, it's the whole point of DeFi and decentralization, right? We're trying to all collaborate and work together. And so with that, we'll probably open source our UI later today, and we have no problem actually. I'm going to show you some of the PsyOptions repositories now. We have no problem letting people in who are looking to compose, so that way they can actually see the source code themselves, because we've just been closed source with our V1 since it's been peer reviewed twice, but it hasn't been properly fully audited. That being said, anyone who's actually doing serious volume on our protocol has access to our repository and all that kind of stuff. So it's definitely no cause for concern there. With that, we have a few more ideas too. So if you're just a hackathon participant and you still have no idea what you're trying to build, reach out to us. We can, we have lots of UIs for these NFT options. People can write covered calls. We just named a few in this Twitter thread, and that's kind of what I was just reading off of. But we're always here to brainstorm and help people get involved and get up to speed on Solana. So with that, if there's no questions thus far, I will jump into the more of the protocol, the PsyOptions instruction set and kind of how they work. Mark, how are we on questions?
We're looking good. Actually, Taylor's in there answering questions. So,
oh, sweet, awesome. Thanks, Taylor. All right, so there's probably 5 or 6, I think, instructions, core instructions for the American V1. The first is initialize option market. What this does is you specify the parameters that are required to create a new option market. The option market, for reference, is it might be this side is just one option market. This is like a BTC call with a $45,000 strike, and the contract size is 0.01 BTC per contract. So initializing the market takes in the parameters that define these non-fungible, non-fungible markets, if you will. And so the key parameters to understand are the underlying asset mint and the quote asset mint. So what that means is, what is the underlying asset that must be locked up into this contract to write this option and give it to someone? So for the BTC call, that's just the BTC mint. And I think we use this Solid BTC bridge mint. The quote asset is what denominates the strike price, what is going to be actually swapped for a contract. It might help if I explain that the protocol doesn't understand anything about calls or puts. You can read a little bit more about that in some of the architecture designs that we have. But what the primitive really does is just helps you write a contract that gives someone the right, but not the obligation to exchange two things at an agreed upon price up until a point in time. And so that's what defines the American option contract. And so the underlying asset mint and quote asset mint are really just defining those two tokens that make up that swap. And then obviously we have the strike price, but we define that as the underlying amount per contract and the quote amount per contract. And that's how you can get the strike price, but also have a flexibility in the contract sizes. So for the BTC markets we see here, to make them more accessible, the premium's not ridiculously priced, we have a contract size of 0.01. So obviously we represent that as a U64 with all the decimals accounted for. for on-chain, but this is how you get that 0.01 contract. And so PsyOptions has the flexibility to make contract sizes of whatever you'd like. You know, if there's a token that's trading a lot lower, you can have contract sizes of 10, 100, 1,000, 15, 25, whatever you want to do. And then you have your quote amount per contract, denoting the amount of USD or whatever you're using. So like we use USDC. So this could be the USDC on that 45,000. So if you have an underlying amount per contract of 0.01 to get the 45,000 BTC strike price, we just use a quote amount contract that is actually 450 because it's 0.01 times 45,000. And then last but not least, of course, like the expiration timestamp, and we use the chain's clock to actually check against those and validate those values. But that's pretty much the gist. Like these core parameters make up a whole new option market. And so with that, minting an option, this is obviously one of the most used features is you actually have to take the underlying asset, lock it up, and mint a covered call. So right now the protocol only to make it completely trustless, the protocol handles covered calls and secured puts. So what that means is if you're going to mint this BTC call, you actually have to put up the 0.01 BTC and lock that into the contract to mint and get this SPL representation of that contract. So then you can go list it on the order book. Someone might buy it, and when they exercise, the program has control of that BTC to actually make that swap. You can read more. I won't go into too many details. That's the gist of it. You can read more on the docs. We'll provide a resource link as well. Exercising the contract is really just, okay, now I bought this option contract from someone or someone transferred it to me. Now my contract's in the money, about to expire. I want to exercise it. So you make a call to the exercise. I think it's called exercise covered call right now, or soon to be renamed to exercise option. But what that does is you actually have to put up the other end of the option contract to get that 0.01 BTC. So for the 45,000 BTC call that we were just discussing, that would be putting up 450 USDC in order to get that 0.01. And so what happens with that is that 450 USDC then goes and gets locked in the contract or into a pool in that option market. You get that 0.01 BTC from the underlying asset pool sent back to you. And then the actual person who was the minter, who wrote the contract writer, has to make another instruction call to get that 450 USDC out of that pool. And that can be done anytime, pre-expiration, post-expiration. If a contract has been exercised or assigned, anyone who holds the writer token for that option contract can actually go in and claim the assets. I guess I forgot to go over a little bit of the two token system with the minting. So I'm just going to go back to that real quick. When you mint the contract, you actually get two tokens. The first is the option token, which is what you're going to sell on the CRM order book if you're using the UI. The second is the writer token, which denotes that you actually wrote the contract, denotes you're short the option. And so this writer token, holding this writer token is what actually gives you that claim on those quote assets when someone exercises. So writer tokens and option tokens are fungible within the specific option market, these specific parameters that were set on initialization. So anyone, if someone gets exercised, or if someone exercises an option token, they're burning the option token and putting up that quote asset, then anyone who has a writer token actually has a claim on these quote assets that are in that pool for that contract or that option market. So then anyone can actually extract the assets using the exchange writer token for quote instruction. And all that does is burns the writer token and then returns the quote amount per contract to the writer's specified destination. If no one exercises at all, then you have to use this close post expiration. So if the market has expired and there's no quote assets in the pool, so there's only underlying assets left, you can then just call the close post expiration. All you need for that is a writer token. It will burn the writer token and then transfer back the underlying amount per contract to you. So if the market expires and things haven't been exercised, well, then you can just use your writer token to get that back, and you don't need the option token. Now, what happens if you want to close out before expiration? Maybe there's a 1 year expiration or something crazy. You'll actually need both the option token and the writer token. So if you sold your option token, maybe things have gone in your favor, and the option tokens, the market is a lot cheaper. You could just go in and buy that option token, and now you have this option token and the writer token for the same market. You can then call the close position instruction, which will burn both tokens and then return the underlying amount per contract back to you. So with that, that's the core instructions here for PsyOptions for the American V1 protocol. And so with this, we get a lot of flexibility in what we can do. I'm just going to reiterate a few more of the unique aspects about how flexible this primitive is and how you can really brainstorm some solutions or some user interfaces that are unique. Because ultimately, our focus is to build something with PsyOptions for the hackathon. So we see here just like a traditional option trading interface, but the PsyOptions American V1 primitive is very flexible in what it can do, that it doesn't have to be just for trading. You can write these American style option contracts if you want to give contributors, some sort of, similar to like in the startup world, incentivized stock options. You can give them a long expiring American style contract that they can choose to exercise up until some point in time. So let's say the DAO has a great contributor that they want to reward, but they don't want to just drop spot tokens on them. Well, the DAO could use the American V1 contract to mint multiple option contracts, lock some of up investing if you want to, all that kind of stuff, to manage this kind of incentivized contributor option pool, if you will. So maybe you have something that's like a 10-year expiration and it gets granted to these contributors, with a 1 year cliff in a traditional 3-year vest or 4-year vest. So 3 years after that. And they're getting these option tokens. So they're not just spot tokens. The user actually has to exercise them at some price point, right? And put up some USDC that actually becomes funding for the foundation. So you can kind of leverage this protocol with a few other things like Bonfita's vesting to really create like a startup incentivized ecosystem or UI or something like that, right? Where you're incentivizing contributors. The other thing is we see liquidity mining protocols that just leverage spot tokens. You can combine the American V1 to plug into some liquidity mining, and that lets you pull all these kinds of levers. You could do a really long expiration, so it doesn't. If you wanted to, you could do a short expiration. You can, we still need to research these subjects. It'll be really interesting, and we want to work with other protocols to try liquidity mining with different expirations, different in the money, out of the money, at the money. But this really just gives you the flexibility to do a liquidity mining program that has all these levers you can pull instead of just being selling at the or dropping at the spot price. You actually now have this infinite spectrum of value that you can add. You can make the option strike price essentially 0, which becomes like the spot price, or you can go closer to at the money to give just a little bit of value based on like what the premium and volatility would value it at, or you can go out of the money and really make these people, it's not worth it for them to exercise at the moment. So maybe they're going to hold longer term until they really see a good value as the project matures, the token appreciates, things like that. So it gives ultimate flexibility in how you want to drop value to these liquidity providers. You can take the same concept and just do it for airdrops as well. You can just mint a ton of options and airdrop them to your community members, the most engaged community members, your NFT holders, That way, instead of just dropping spot tokens that these holders or members are just receiving for free, and they're selling maybe because there's a tax burden, they're selling because maybe they've just held on this NFT and maybe they don't believe in the project, whatever it may be, you have these other levers to pull with the kind of value that you're dropping. And even if it's in the money and there's good value in that option, well, they still have to put up some USDC or whatever that quote asset is that you set on that option to exercise and get the actual spot tokens out. And that in turn just gives the foundation and the DAO more funding versus if you were just airdropping tokens, you're just giving away value, and there's potential selling pressure from those who just received free value or maybe have a tax burden that they have to realize with that. All right. There's a lot of talking. Mark, any questions?
None so far.
All right. I think I'm going to jump into workshop coding. So we're on the this is the PsyOptions, originally Solana options from back in the day, repository that we have, where I actually last week rewrote the American protocol in Anchor. So this is not the current running version, but this is the program rewritten with Anchor. So I'm going to use that actually to do the cross-program invocation. What we're building here is the primitive doesn't actually do auto exercise. And so that can be a pain point for people if they aren't paying attention, or right now there's no on-chain alerts or notifications. Hopefully our friends at Goo will get those out there at some point. I know they're working hard, but it's still nice to have something that just auto exercises. So you don't have to be paying attention up until the point of expiration, and you can kind of build in, is it in the money or out of the money with an Oracle, and then just have this I'm going to call it the brokerage program because it can be extrapolated to a lot of other nice to haves built on top of PsyOptions. But this could exercise for you. And so what we're going to build is we did a little prep for this. So we have this brokerage protocol that we can initialize a new vault for an option vault for some wallet address. And on initialize, just to make things simple, we take in an amount of options that we want to go in there. And you see that it'll just transfer that from the option source to the vault using the user's authority. And that's pretty much the gist. We don't have any real, we haven't dug into security here or anything like that. So we've just kept it very plain and simple. And so we like to do a lot of TDD. So that's what makes Anchor really nice when you're doing all your tests in JavaScript. It makes it a lot more familiar for people. So we have some basic setup here for this exercise. I'm realizing this is probably really small for people. So let me just do this. Is that more legible? Mark, is that legible? I feel like there's serious lag on my end.
That's looking better.
Okay. So, all right, we're setting up this exercise test where we basically, we need to set up an option market with PsyOptions because this brokerage protocol assumes that it already exists. We need to mint some options while the market's not expired. We need to initialize a vault. And then we finally get into, this is all kind of just basic setup for what we need to have on chain. And then we get into actually cranking or using this exercise request that makes a cross-program invocation to the American V1 and exercises options on behalf of a user. So I'm going to just go into a little bit about this setup. So I'm going to assume everyone's kind of familiar with Anchor to some degree. So we kind of have these payers and this provider that Anchor has. And that's kind of where we have our workspace that has our 2 programs that it is deploying when we build. And then we have a lot of different variables that we're going to use for these tests that need to be accessible in setup and future tests. So we pull them outside of the actual each test. Here we just have a function that just calls the American Mint option, just a helper function. Could probably be cleaned up and pulled out into a utility, but for now we're just moving quickly as we do in crypto, and we can always clean up the code later. We airdrop some Solana to our users' keys and our payers' keys, just so that we have, so we can actually call instructions. Here we actually do an initialize setup to create an option market. I'm not going to dive all the way into this, but it's really just, it's going to create the underlying quote mints. So just creating some SPL tokens that the test can use. It's going to create some associated token accounts, because the PsyOptions program does take a 5 bips fee for mint and a 5 bips fee for exercise if it's there, like if it's not an NFT market, and creates those accounts. Then it also creates creates the option market. And so we can see that we have kind of all these accounts, or sets up for an option market. And I believe we actually initialize the option market here. And so you can just imagine that this is all a lot of test setup. And then this right here is actually initializing the option market, calling that initialize option market function that we went over in the architecture. And then we're just creating an option token instance just for ease of use on future tests. We have this helper function that creates a minter. What that does is just creates a new account with an option account, an underlying asset account, quote asset account, writer token account. This is all handled typically by the user interface. If it recognizes your wallet doesn't have these accounts, it creates them for you. So for running these actual tests, we have to do all of this setup ourselves, creating the quote accounts, creating the underlying accounts, creating the option account, creating the writer account, and then here we actually send the transactions to create all those accounts. And then to actually be able to mint options or exercise options if we want, we need to actually have underlying tokens. So here we're using the SPL program to mint tokens to those newly created accounts. And this is an argument passed in for the underlying amount, and then argument passed in for the quote amount. And we return all these new accounts back to the tests for use. And then now that we actually have the minter, we use that. This is that helper function that we defined above that actually mints these options to this newly created minter. And now we pretty much have like the full setup from like the PsyOptions perspective of like what's needed. We have an option market, we have a minter with enough assets, and then we actually minted some options to that newly created minter and their associated accounts. So now we want this minter to have these options in the brokerage vault. Again, this could be done by the user interface where it's very seamless. So like things get a little bit more granular when we do tests, but you could imagine a user interface that makes one transaction to mint these options, and then immediately like in the same wallet signature makes a second transaction or separate instruction that mints them to this vault or transfers them to this vault. So you could do it, make it very clean from a user perspective, but when really running good tests, we have to do all this setup in sequence here. And so we just going to transfer these options when we initialize the vault here. So this is actually going to be interacting with that, with the, where are we at? Wrong one. With the brokerage protocol, the initialize. So we can see that we have this, program is the brokerage protocol, and we're using the anchor helpers here to actually initialize, and we have the size. So this is the number of options. So we're just actually initializing the vault with one option. And then these are the accounts that the initialize takes, the signer, and here we have the vault account. So now imagine this all goes well. We have this minter who has minted these options. They just transferred and initialized this vault and put them in there. And now, now we should, in theory, if the market's not expired, which we set the market to expired an hour from right here, when actually creating the market, then we can actually just test the exercise because we don't have to wait until an exact point in time, since this is an American style option protocol. So we can now actually just assert, like, let's just do a sanity check here and validate that the vault has options in it. So we'll do assert equal vault account. The vault account is already an option token account. So we can just do amount, and we'll do toString so we can easily compare. And we'll do, it should be size, since the size is what we transferred. And so this should actually run, okay. And so let's filter out the tests because we have a ton of tests unrelated to this exercise. So it's building 2 programs. See this a few more times as we do this. I'm just going to run it. There we go. So we know that we have, and if you guys want to see a sanity check, we could just like log this, but we can validate that there is actual amount in the vault. But while that's running, clear this out and start writing our other tests. So we need to actually make sure that the minter received the underlying assets. So what we can do, oh look, there we go. There's one option in there in the vault. So we need to check we're going to write a test, a failing test here, and then we're going to dive into the actual like Rust code. And I'll try and speed things up a bit since I am user underlying before equals underlying token dot get account info. Account the key. So this, if we actually await it, should return the account info for the underlying token, that is the user's underlying account. So this can give us the balance before we actually make a call. And then we'll do the same thing. And this is after the call should be made. And so we'll just actually take the difference. We'll do user underlying after dot amount. Let's subtract from the before. And that should be the difference. And then we'll actually make the assertion here, assert dot equal. So we know it should transfer the underlying amount per contract times the size of the that are in the vault back to the user's underlying account. So we're going to assert that the user's underlying difference. What is this? Oh, this is already a amount. The user underlying difference is the size multiplied by the option market underlying amount per contract. And we'll do toString for comparison. And now this test should fail. Cool. So now we have to actually write an exercise function inside the brokerage protocol to handle this. So we'll do a new account structure. I believe that's the pattern. Yep. And we'll just start with just the authority percentage check, and we will do. I actually have to create the instruction if I can type. We're just going to do something. We're going to keep it simple and actually just have it exercise all the contracts in the vault. So it's not going to take in an amount or anything like that. And we'll return, okay, here. So now like we have this basic template for an exercise instruction. So we'll actually just start filling out, actually making the call to the program's exercise function. So we're back on the client side here using the anchors helper stuff. And since there's no arguments, we just pass in the options, which is the account, and we'll do the authority is the user's public key, and the signers, the user, which is a key pair. And it should run fine without error and still just give us the same assertion error here. While that's going, I'll probably jump into a little bit more. Cool. So now we have to like actually work on the cross-program invocation call. So of course we're going to need the American program's ID. So we're going to pass this in here. We're going to do the American program, and that would be the American option program ID. And we need the vault authority because we know that we need, we have this vault authority that owns the actual vault. So we're going to pass that in as initialized. I think I already defined this in a variable when I was setting up the tests. Let's validate that. Yeah, cool, sweet. So again, this should like run, everything should be fine. It should still be failing, same place. As that's running, I'm just gonna keep for speed here. I'm gonna just go through some other stuff. So we have this is the PsyOptions American V1 rewritten in Anchor. And so here we have this exercise option account struct, which is used in the actual exercise option function. So we see it's this exercise option here, which basically just burns the option tokens, transfers the quote assets to the pool, transfers the underlying assets from the pool to the exerciser. If there's a fee taken, it takes that fee, and then boom, we're done. That's like exercise in a nutshell. Probably more easier said than done, right? And so with that, we have the exercise option account structure that we need to pass in. So we can pretty much just rip all of this and take it over to the accounts we have on the other one. Okay, and so now we need to start filling in this information. into the actual exercise. So we have option market, option mint, exerciser. That would not work. Should be the user option account public key. And we have the underlying pool. So, I mean, I'm going to assume everyone is familiar with some of the Solana basics. If anyone has questions offline about what I'm doing here and why I need to pass in all this information, happy to answer that offline. But basically, need to pass in every single account that gets, or every single like public key for an account that gets acted on here. And you can see here that we're specifying that these are mutable because they're going to actually, all of these are assets are being transferred, whether it's in them or out of them. So we just have to, that's the beauty of Solana. It has the parallelization of these accounts and why it runs so fast. Actually, quote asset source would be user quote accounts. Set up all these accounts, these user quote accounts, user underlying accounts, they all come from this like create minter setup here. You can see them being assigned here. And we have the fee owner, which fee owner is a constant. We have the token program. Okay. If everything is done well here and we passed in all the accounts and didn't have any typos, oh, what do we got here? Oh, option market is not found as this scope. So we have the CPI account option market, which really comes from the PsyOptions option market. So this is that option market that we initialized here, this struct. So we actually have to import that from the crate. So we'll use Psy American, and then we'll do option market. Here we go. Now we should build and run. That definition is actually just using this cargo, or like the dependency is specified here. So right here, we're just loading it locally, which is this program right here. Cool. So it looks like all the accounts like passed in correctly. Close that out. So now we actually have to do the cross-program invocation, where we have to specify all the accounts. So we need to do the CPI program is the accounts for the Psy American program. Clone it, and then we need to do the CPI accounts. Okay, we also need to import the exercise option struct that we have here. Takes me to it. Because this is what we're specifying for the actual CPI context. CPI is just cross-program invocation. It's going over anyone's head. And so now we'll do this exercise option. And now we have to type out all of these accounts. So the user authority is just going to be our authority. We have the option authority, which is going to be the vault authority, which has access to the options we put in there. We have the option market, which is, we already passed in here, I think I need to come and make it into, because this option market expects a program account. So we're just going to coerce it into from a CPI account to a program account. What else do we have? We have option mint. So here's the trying. Underlying asset destination. I love autocomplete. Want a fee owner. Any questions while I'm typing all this stuff out?
Yeah, somebody was wondering if you have time, if you can show an example emit event and like how to consume it in TypeScript.
Sample emit event.
Or an example.
Of emitting an event. I'm not sure what they. I actually don't use emit events at all in any of this stuff. I can write it just later if they want that. Okay, so now we have the accounts set up for this exercise option. And then we need to actually make, we need to generate the signer for the cross-program invocation, because we need to sign this transaction that transfers from the vault. So that way PsyOptions knows, or Solana knows, that we actually have access to the options in this vault. So we're going to generate the seeds. And it's going to mimic exactly how we did the vault for the initialized stuff. So you can see here that the vault authority is the option market key, and then the text vault authority. So we'll do key.as. Yeah. Vault authority. Oh, we need a bump seed from the vault authority that came from here. So we actually need to pass this in as a U8. And so now we actually have a new argument that needs to come before these accounts. So vault authority bump. And then we can pass this in here. And we have this signer equals okay, now we're creating the CPI context. Comes from Anchor. You do it with a signer. So we have the program account. So we already extract that with CPI program. We have the accounts, which we already did with CPI accounts. And then we have signer, which we extracted above. And finally, we need to actually call the CPI to exercise the option with the CPI context and because the exercise option takes in an amount, we need to use the amount. We're not doing any checks here, so we're just taking in all of the source of the exercise options token source, which is the vault that we initialized, and passing in the amount as the amount that should be exercised. And this is actually probably going to fail now that I think about it, because we didn't pass in the fee key properly. And so I believe this owner does not match the burn. What do we got here? I need to make sure this is. Oh, this needs to be. Oh, I thought I changed this. Hold on. It's been hard with the oh, this is burn. This is good. There's our option authority here. It's getting hard with this tiny screen here. Oh, we did vault authority, which should be correct. So we have the bump properly set up. That's not found and close. Sorry. Oh, we want to get rid of that. Did we pass in the vault authority? I think maybe we forgot to pass in the. What is it? Authority, program, vault authority, option, market, option, mint, exercise option, token source. What asset? What asset pool? I'm wondering if. All right, I'm going to my cheat sheet here, since we are time constrained. And just like magic, it works. Okay. All right, so there's one thing I wanted to show you guys, but I'm looking at the time and it's definitely been an hour. But so one thing that we were running into, I ran into when like messing around with this on a flight yesterday, was the that I wanted to touch on for Anchor. The exercise option function here, we use optional accounts when doing the fees. So if you look at this, at the fee structure here, we do validate exercise fee accounts and we pass in the remaining accounts. So you can, in Anchor, you can have optional accounts. You just have to use the remaining accounts array and pass them into an instruction. And then just like if you're used to Solana native, you just use your iterate across those accounts. But if you accidentally, or if you call next account info and there's nothing in that iterable, or yeah, the program's going to panic. And so initially, like we forgot to put in that exercise fee account. And so you see this updated test here that actually just checks if there's an, exercise fee, adds that to the remaining accounts and passes it in here. And then it's good to note when you're trying to do a cross-program invocation for a instruction that has optional accounts, you need to actually just set the context remaining accounts. Well, you need a mutable context, then you can set the remaining accounts here. Because this new assigner actually doesn't take in, you just see it initializes an remaining accounts vector. So that's why we have this mutable context that we then add the remaining accounts to, and that all gets passed into the exercise option. And then things don't fail with that. Sweet. I'll probably wrap it up with the live coding here. I don't know if there's any more questions that I should address. The emit thing, I actually don't use emit or haven't used emit yet, but I could definitely, if you want to ping me or jump in our Discord in the ignition, I'm happy to throw something together if it helps you, if you're interested in working on top of PsyOptions. We're here to provide resources and help where we can. So with that, I just want to reiterate, we have a $30,000 prize that we're sponsoring for those who build on top of PsyOptions. We're really looking, it can be user interfaces, it can be other protocols that leverage, I think liquidity mining, option liquidity mining would be really cool if someone already can take a liquidity mining program and implement PsyOptions into that. I think Mago has a good liquidity mining program that plugs into Serum. So it'd be really interesting to maybe to work with them on that. I think another really, really cool thing is all the stuff that can be done with the American V1 in regards to incentivizing contributors and things like that. So a user interface where you can simply manage these incentivized options or incentivized contributor options. We'll call them ICOs instead of ISOs, or ISOs like we see in the traditional world. But the trading view is like very, very complex, and you could make something much more simple for managing those options that aren't really just for trading. I mean, we have this portfolio page, but again, I'm thinking a very simple UI. And then I think there's a lot of cool stuff that can be done with NFTs that just hasn't even been explored or researched. Again, like we're here to brainstorm. So if you're not sure what to build, jump into our Discord, jump into our Telegram. Everyone in there is very friendly and happy to bounce ideas around. Cool.
Sweet. Thanks so much for joining, Tommy. Looking forward to seeing you on the next one.
Thanks for having us. Looking forward to it. Happy hacking.